Dear students, how are you all? We are in chapter 1, that is number system. In this lesson, I am going to discuss about expressing terminating decimal expansion in P by Q form. As we earlier read that decimal expansion of rational number can be of two forms, that is, one is terminating decimal expansion and other is non-terminating repeating decimal expansion. So first of all, we are doing representation of terminating decimal expansion in P by Q form. So first of all, read the procedure. The procedure says count number of terms in the terminating decimal expansion and put that number of zeros in the denominator, and then convert that rational number in its simple form, that is, by eliminating common factors from numerator and denominator. For an example, express 3.125 in form of P by Q. For that, first of all, we have to count the number of decimal points. These are 3, 1, 2 and 3. 3 decimal points are present, so we have to place 1000, that is 3 zeros in the denominator. I am repeating here, there are 3 decimal points in the decimal expansion, so we have to put 3 zeros in the denominator. Now cut the common factors of both numerator and denominator and you will get 25 by 8. Thus we can express 3.125 in P by Q form. Next is expressing non-terminating recurring decimal expansion in P by Q form. For example, first of all, we have to assume that number is x. So let x is equal to 0.888 and these 3 dots represent the number is non-terminating, and because 8 is coming again and again, so we can say that it is non-terminating recurring decimal expansion. So now as there are infinite decimal points present, so we cannot put like we have did in the previous procedure. So we have to follow the second procedure for this. First of all, multiply this x with 10. So if I want to multiply this x with 10, I also have to multiply the complete expression with 10 also. Now it will become 8.888. Now look, see carefully, there are 888 up to infinite and there are also 888 up to infinite. If I am subtracting these two equations, that is equation 2 minus equation 1, what I will get? I will get an 8 and here I will get an 9x. So I am writing here subtract both equations, that is equation 2 minus equation 1. Now 10x minus x is equal to 8.888 up to infinite minus 0.888 up to infinite. By this way, all the recurring 8 up to infinite in both the expression will cancel out each other and we are left with 9x is equal to 8 and x is equal to 8 by 9. By this way, 0.888 up to infinite can be, take one more example, express 5.8777 up to infinite in form of P by Q. We have to follow the same procedure which we have did in our previous example. Now let x is equal to 5.8777 up to infinite. Now I am going to multiply the complete equation 1 with 10. So here 10x is equal to 58.777 up to infinite. Now just compare these two equations. What if I will subtract these two? Do I get the complete 0 after decimal point? No. Why? Because there is an 8 and there is 7. So we cannot subtract these two equations by getting zeros after decimal point. So what is the next step? In our next step, I am going to multiply the equation number 2 with 10 again. So 10x when multiplied with 10 will give us 100x, and this equation will become 587.7777. Now analyze equation 2 and equation 3. What if I will subtract equation 2 and equation 3? Because we have to eliminate all the terms after decimal point to 0. Now look these two terms. There are 777, that is recurring 7 up to infinite, and there are also 777, that is recurring 7 up to infinite. If I am going to subtract these two equations, I will get 0 after decimal point, and you all know that 0 doesn't have any significance after decimal point. Now I am subtracting equation 2 and equation 3. So in left hand side part I am writing here 100x minus 10x, and in right hand side part I am writing 587.77 up to infinite minus 58.77 up to infinite. Now 100x minus 10x gives you 90x, and 587 minus 58.7 gives us 529. So x is equal to 529 by 90. Now check for any common term in these two. If there is, so you can cancel that common term. If there is no common term present, then you can put this x like the same way. Next step, representing real number on number line. What if we have 2 or 3 decimal point expansion? Because we know that in our scale we have 10 points between 2 and 3. Just like look at this picture. This is our scale. For example, our scale is starting from 0 to 1. This is 1 centimeter measurement, 1 to 2. This is again 1 centimeter measurement, and we all know that there are 10 parts in between 2 and 3. So if someone told you express 2.5 for number line, so what you have to do, you need to put a point here and you can represent that this is 2.5. What if someone told you express 0.3 on the number line, so this is 0, and after 3 lines, that is this one, you can express 0.3 here. But what if someone told you express 2.665 on number line? So for that case, we know that we cannot express 2.665 directly on the number line. So just follow the procedure, and you have to draw this diagram also in your answer sheet for doing the same type of questions. So first of all, we need to express 2.6. So if I am putting a magnified glass here, what will happen? The particular part is shown here again, because I am showing this with the help of a magnified glass. So this is your 2 and this is your 3, and the small lines which are 10 in counting are shown here. This is 2.1, this is 2.2, 2.3, 2.4, 2.5. The bigger one is the midest part, so this is 2.5 this way. Now, as we know that 2.66 lies between 2.6 and 2.7. 2.6 and 2.7. Now we have to put this magnified glass over here, and we have to enlarge this particular part. As we already know that there are infinite rational and infinite irrational numbers between two integers on the number line. So we can express as many number as we have in any 2 points on the number line. So next step is, now if this is 2.660 and this is 2.670, so this particular line will be 2.661 this way. this one 2.665. This is the 2.665, and by this way we can represent any given decimal point expansion up to given points on the number line. Next is representing root x on number line. How can we express any real number which is under a square root on number line? For that we have to follow a simple construction or geometric construction part. So just follow the simple steps. The step number 1 says draw a line. Suppose I am going to represent root 3.5 on number line. So first of all we have to measure 3.5. So first step is draw a line AB of 3.5. This is your AB, A to B, and with the help of scale draw a line AB which is of 3.5 centimeter. Now next step says you have to extend this line up to 1 centimeter and put that point C. Okay, now AC is total of 4.5 centimeter length. Now the length of AC is 4.5 centimeter. For the next step you have to mark the midpoint of the line. As you know that we can do the perpendicular bisector of the line with the help of compass easily. So draw a perpendicular bisector, and this O is the midpoint of the line segment AC. Now measure this AO. This will be your radius, and put your compass here and draw a semicircle. Draw a semicircle on taking AO as radius. Now for the next step, at point B you have to draw a perpendicular line here. That means with this reference line, the line BD make 90-degree angle. You can do this with the help of protractor. Put your protractor here, this is your reference line, and make the point for 90-degree angle and join the line BD up to the circumference of the semicircle only. Now this length, this BD is actually root 3.5. How can you verify your answer, this is correct or not? Just measure this with the help of your scale, and you know that how to find under root by long division method. So you can calculate 3.5 by long division method, and you will get that the measurement of this length is equal to the result which you have find by calculating root 3.5 by long division method. Now up to this step, actually root 3.5 is not representing on number line. For that we have to put compass here and measure BD and draw an arc this way, and let the point is E, So BE is actually BD, and this is of the length root 3.5.